Hello guys, you are welcome back to Science Arena Academy. Today, we'll be taking a look at speed, velocity and acceleration. In my previous video, we take a look at position, distance and displacement, which are what can be used to describe the study of motion based on kinematic altogether. Now, but before we start today's class, if you are new to my channel, please don't forget to click on the subscribe button, and don't only click on that subscribe button only. Click on the like button to like the video and share with your friends, so it will makes us to be happy and be able to produce more videos, more content that will be helpful for you in your examination. Now, today we'll be starting with this greater quantity: speed, velocity and acceleration. Speed, velocity and acceleration. The first thing that we need to take a look at is, what is speed? Now, why do we need to understand each of these quantity one by one? Altogether, how does this quantity describe the complete motion of a body? Now, let's take an example. When we are in a moving car, we notice that the speedometer of the car tells us how fast we are moving. Altogether, now you know every car always have a speedometer in your dashboard. Now, the function of the speedometer is to be telling us how far the car is going. Altogether, now majorly our speedometer only gives us our speed, how we are going. Now, what does that mean? It simply says that if I have a speed of, let's say, 10 meters per second, for instance, if the speedometer is indicating a speed of 10 meters per second, for instance, what this thing simply means is that the car is covering a distance of 10 meters in every 1 second. Altogether, let me assume that we have a distance here. If the car is positioned along this direction here, this is the car. Now, if at point A, the car is at here, the car will cover the distance from point A to point B is 10 meters. Now, the car covers from B to C is also under 10 meters. From C to D is under 10 meters. It simply means the car is a car that has a speed of 10 meters per second is moving for every 1 second a distance of 10 meters. 10 meters is stand for what? For every 1 second. That's what the car is covering. Now we can easily calculate the total speed that the car has altogether. Now, normally our speed altogether, our total speed that the car has is always the total distance covered by the body. Let me say the total speed of the car. Let me try to remove this from here and try to write something out. Okay, sorry. Now, look at something here. The total speed of the car, let me say the speed, our speed of the car will always be given as equals to total distance covered, total distance that is covered by the car, all over time taken to cover that distance. This is what our speed. Now, note something, that our speed, the speed of a car, or let me say the speed of a body, is independent of the part that is being taken by the body. Altogether, don't forget that when we want to calculate for the speed, we only make use of the total distance that is covered by the body, all over the time taken to cover that distance. So, because the speed is independent of the path taken by a body, let's take for instance, assuming the body is going along this path like this, let me say it's going like this, now we can easily calculate the speed of the body from initial point to the final point. Now, no matter how changing direction the body is, now, the speed does not depend on how the body is changing in direction. So the speed is just talking about the total length of movement from the initial point to final point, total distance that is covered by the body, all over time taken to cover each of these distance. That is what our speed is all about. So speed is equal to the total distance covered by the body over the total time taken by that body. This is our speed. So because of this, a speed is a quantity that is independent on the direction of movement. So the speed only depends on the magnitude of it only has a magnitude without a direction. It simply means we can describe the speed of a body only with the magnitude, but the direction of the body is not that important to us altogether. So this speed is said to be a scalar quantity. A scalar quantity. Why? Because it can only be described with a magnitude without a direction. Hope you are following up with this thing that is getting now. Now, in real life situation, it is highly important to describe the motion of a body by including the direction in which the body is traveling altogether. So if a body's speed is being described with the direction of travel, then the speed is otherwise known as velocity. Not a speed, it's velocity. So velocity depends on displacement of a body, unlike speed. Speed depends on distance, while velocity depends on what? Displacement. Now let's take a look at this. Let's say I have a body that is moving along a straight line like this. So if a body is moving along a straight line, it started from point A and ended in point B altogether. Now, the displacement of the body here is simply the distance from point A to the distance from point what? To B altogether. This is my displacement. It can be taken as change x. So, you see, don't forget that in this place here, we have to consider the total distance, total displacement of the body from point A to point B. So our velocity of this body, because this body is only going along a single direction, here we are describing the motion of the body, are you getting, by including the direction of the movement. So in this case here, we are describing the velocity of the body. So what is velocity? Are you getting what I'm saying now? Velocity, though before we start the definition of velocity, a body can have different forms of velocity. We can either have an average velocity of a body, average velocity, or we have average velocity, or we have instantaneous velocity. Instantaneous velocity. Now, let's take a look at both of them one after the other. Now, you see, when do we have average velocity? And what is the velocity itself? Now, take note. Average velocity is simply the rate of change of displacement of a body altogether, the rate of change of displacement of a body. Now, what does that mean? It simply means the velocity that we calculated when we consider only the initial position and the final position of the body. Okay, let me say, for instance, now the body is starting from point A. It's starting from point A here. We started the motion of the body from point A here, and we only wait till we get to point B before we calculate the velocity of the body. Then this kind of velocity here is known as average. Average. Why? Because the velocity is only calculated by using the initial starting point and the final point of the body. So this velocity that is calculated using only the initial and final is known as the average velocity. So our average velocity is always defined as the rate of change of displacement with time taken. Although in physics, whenever they include the word rate in any definition, please note that whenever they are using the word rate in physics, rate simply means with respect to time. Altogether, that means the body is moving with respect to time. Now, another thing I want you to know is that since this velocity depends on the direction of travel of the body altogether, velocity is a vector quantity. Now, what differentiates this velocity with speed? What is the difference between a velocity and a speed? Don't forget that velocity is the same as speed. Why do we say that? Altogether, the magnitude of velocity is the same thing as what? Speed. Altogether, like that. But what differentiates between velocity and speed is that velocity can fully be described with a direction, while speed can only be described with magnitude. It simply shows that speed is a scalar quantity, while velocity is a vector quantity. These are the two quantities that we have in physics. Some quantities are scalar, while some quantities are what? Vector. To just recall, a scalar quantity is a quantity that can be described only with a magnitude, while a vector quantity is a quantity that can be described with both magnitude and direction altogether. Now, note something, that since speed and velocity, they are both the same, just that they are just in terms of direction, they differ in terms of direction altogether. So speed and velocity can be measured using the same unit, which is meter per seconds altogether. Now, this for average velocity. Now, what about instantaneous? Talking about instantaneous velocity altogether, instantaneous velocity, instantaneous velocity. What do you mean by instantaneous velocity? Now, let's take, for instance, let's go back to our initial example of the speedometer of a car altogether. Now, do you know something, that the speedometer of a car measures the speed at every instant of time? Do you know that? the speedometer of a car always measures the speed of a body at every instant of time. Now, you see, since speed is a magnitude of velocity, don't forget I said earlier on that speed is a magnitude of velocity vector. Altogether, velocity can also be measured at every instant of time. Altogether, now, our speedometer measures the speed. Simply means the kind of speed that is measured by speedometer is instantaneous speed. Why is it instantaneous? Because this speed is measured at every instant of time. This is what I mean by instantaneous. Let me assume that the body is going like this, along this direction. I'm talking about speed. Now, when I move from here, I only move a little step ahead of myself here, from here to here. My time, don't forget that there is a change in time from here to here. There is a change in time here. Now, I also move to this point here. Look at all these initial points that we can move. Let me try to use something that will work. So I can move at all these initial points here. Look at it here. We can be moving at each of these initial points here. At this point, this point, this point, this point, this point here. Now, you notice that we only have an infinitesimal distance. If a body is covering an infinitesimal distance altogether, now, and is now moving at without infinite time altogether, the distance that the body is covering is so small to the extent that what? We can't calculate for the body. Are you getting what I'm saying now? The distance is known as infinitesimal distance. So the speed that the body will be having at that instant, let me say from point A to point B, the distance from here to here is only infinitesimal. Altogether, from here to here is only infinitesimal distance like this. Now, at each of this distance, we normally calculate our speed at each distance. When we get here, we also calculate speed. Here, we also calculate speed. Altogether, the speed that is being calculated at each of this infinitesimal distance is what we call an instantaneous speed. Altogether, so the same way we can also have, because we said earlier on that a speed is a magnitude of a velocity vector, automatically we can also calculate a velocity of the body at an infinite distance. Altogether, the velocity that is calculated at an infinite distance altogether is what we call an instantaneous velocity. Or let me say, the velocity that is calculated at every instant of time is known as an instantaneous velocity. Altogether, now you see one thing is that the velocity measured at every infinitesimal time is known as instantaneous velocity. Now, since it is an infinitesimal changes altogether, we normally require another forms of this, which is a derivative. Don't forget that average velocity, as I think I didn't give that, average velocity is always a change in displacement with, let's use S as our displacement, change in displacement all over change in time taken. Now, this change here is simply a derivative. It's simply what? Known as delta. Delta, which indicates change. Now, it simply indicates a change in final quantity all over minus initial quantity. So the final and initial quantity. Now, but whenever we are referring to an instantaneous velocity, are we getting what I'm saying now? This our change, which is average, change in displacement over change in time, are you getting me? Will be gotten in what? An infinite time. So it simply means this our change, which is our velocity, is taken as change in S over change in time. Are you getting what I'm saying now? Will be limited. Now, when we limit this by taking change in time to tend to 0, that means when we tend to limit this time, this derivative, it is being limited to differentiation of the S or derivative of S with respect to time t. Are you getting me? So my velocity is always equals to ds dt. So this velocity that we normally calculate using ds dt is your instant velocity, which is known as instantaneous velocity. Now don't forget that what? This instantaneous velocity also have the same unit as your normal velocity, just that it's a kind of, in this case here, you'll be given a question in form of a function. Are you getting me? Maybe they will give you x, which is the distance, as a function of time. S will be given to you as a function of time. Let's say s is equals to a t raised to power n. X, which is the displacement, will be given as a function of time. Now, in this case here, please note, I said s is equals to a function of time. X, let me write it very well. S is a derivative, or is a function of time t. Altogether, so we have a t raised to power n. Altogether, that is my s as a function of time. Now, how do we now find my ds dt? My ds dt will be equals to a multiplied by n t raised power n minus 1. This is the formula for calculating it, where this a is a constant term altogether, and this n indicates the power. We have the power, and this a is my coefficient, and this t here is our variable that we want to differentiate first. Let's take an example on this so that we can know how we can solve this in exam altogether. Now, assuming you have something of this kind here, I have x equals to 2t raised power 3 minus 3t. How do we do this? Now, we have to find the s and over dt. How do we solve? Now, if you apply our formula, don't forget that we said the s dt is equals to a n t n altogether minus 1. Now, what is my a in this place here? Now, we are going to differentiate them one by one. I will differentiate this separately. I will differentiate this separately. And I will differentiate this separately. Altogether. Now, each of them are both function of time. Altogether. So, from here, I'll be having something of this kind here. Let me use something else. Now, I'll be having something of this kind here. Now, my a is 2, which is the coefficient of the variable t. My power is 3. So, I'll be having 2 multiplied by 3 altogether. Then t raised to power 3 minus 1. Now, minus this one also. The power of this one is 1. So, I'll be having 3 multiplied by 1 altogether. T raised to power 1 minus 1. Then from here, we can easily have 6 t raised to power 2. And this one is minus. Now, this is 3 t raised to power 0. Now, I can have my final answer as 6t squared minus 3. Why? Because anything raised to power 0 is equals to 1. T raised to power 0 will be equals to 1 here. So your final answer should be equals to 6t squared minus 3. That is the derivative of s with respect to what? To time t. Altogether. So whenever you have to give a question on instantaneous speed or velocity, don't forget that your displacement will be given as a function of time altogether. So if your displacement is given as a function of time, here they gave us this as a function of time t. So if my displacement is given as a function of time, like this one that is here, then we can easily follow each of these steps here to derive the value of the ds dt. Since this my ds dt is equals to velocity, don't forget, this is my velocity. ds dt is what? Our velocity. I will together with me like that, so we can get this. Now let's move on to the third quantity that I want to talk about, which is the acceleration. The third quantity is acceleration that I want to use to describe the motion. Acceleration. Now, what is acceleration? Altogether. Now you see, as displacement, as velocity depends on displacement, so likewise acceleration also depends on velocity of a body. Altogether. So what is my acceleration? Acceleration is the rate of change of velocity. It is always the rate of change of velocity. Rate of change of velocity. That is my acceleration. It is the rate of change of velocity. Now, that is how a body speed, and direction changes. Altogether, what acceleration is talking about is how the speed of a body and the direction changes. That's what acceleration is all about. So in a nutshell, acceleration A is always equals to change in velocity all over time taken. Now don't forget that when I was explaining to you about average velocity, whenever they use the word change altogether, then they are referring to an average altogether. So here, this acceleration that is defined here is the same as, let's say, our average acceleration, which is always equals to change in v over change in time taken. Altogether like that. Now, note something, that the unit of acceleration altogether. Okay, let me put it in this place here. The unit of acceleration is meter per second square. Altogether, that is our unit of acceleration. And also take note of something, that this acceleration that is here is simply a vector quantity altogether. And again, note something, that this acceleration only depends, the average acceleration depends on the initial and the final point of the body. Simply means it does not depend on the path that is taken, it depends on the path that is taken by the body to get to the final position. All together like that. So we have this as our acceleration. Now, the same way we can have an instantaneous velocity, we can also have an instantaneous acceleration. All together like that. Now, instantaneous acceleration is also defined as the acceleration at an instant of time. Acceleration at an instant of time is known as instantaneous acceleration. Is known as instantaneous acceleration. Altogether, that's what we call what? Altogether. So that is that. Now, let's now find how to find our instantaneous acceleration. Don't forget I said instantaneous velocity, which is velocity at every instant of time, is taken as how dx all over dt altogether. Now, again, we said our average acceleration, and try to remove this. Now, if I have this as my average acceleration, is always equals to change in v over change in time. If this is being limited, if you limit change in time and make it what? Limited to 0, then this will equals to dv over dt. That means derivative of velocity with respect to time. And since derivative of velocity with respect to time is equals to ds over dt, then my instantaneous acceleration should be equals to d over dt into brackets. V is ds over dt, which will give rise to it is going to give us this, okay, to give rise to d over dt into what ds over dt will give rise to d2s dt square. That is our instantaneous velocity. Simply means we can express instantaneous acceleration, as dv all over dt altogether, or which is also equals to what? d2x over what? dt square altogether. Now, this is our instantaneous acceleration. Now, let's take an example on each of these things that we've done on both speed, velocity, and time altogether. Let's take a look at this example that will be shown to us here. Now, the first example one that we have is shown on the board altogether. They said a car is traveling along a straight highway at a speed of 20 meters per second altogether. At a speed of 20 meters per second, the speed that is given to us is an initial speed, which is equal to 20 meters per second altogether. They said the driver steps on the gas pedal altogether, and 3 seconds later, the car speed is 32 meters per second. The final speed of the car is 32 meters per second altogether. Now, they say find the average acceleration. Now, before I solve this question, I want to explain something. You see, the acceleration we're referring to can either be a positive acceleration altogether or a negative acceleration altogether. Now, when do we have positive acceleration? When do we have negative acceleration altogether? Now, when your initial speed here, when my initial speed, which is taken as this u represents initial velocity or initial speed, and v represents final speed. When the initial speed is less than the final speed, then we have a positive acceleration. Simply means that is our what average acceleration. But when the initial speed is greater than the final speed, we have a negative acceleration, which is otherwise known as retardation. Now, when do we have this? And when do we know? When do we know the acceleration given to us is negative and the acceleration given to us is positive? Sometimes there's always a question that's always going like this. Whenever they give you a question, they said a car starts from rest. I will get to answer now. On meeting an obstacle, the driver applies a brake. Now, one thing about it is that whenever a brake is being applied on a car, the brake is going to reduce the velocity of the body, are you getting me, to a barest minimum, such that the initial velocity will be more than the final velocity. Then we are talking about this aspect here, which is retardation. All together, then you should know that your acceleration will be minus acceleration, which is negative. All together like that. So that's when we normally have a negative acceleration. But when a brake is not being applied, I'll get something now. When a brake is not applied, the body will continue to have a positive acceleration. Another name that you can give to this retardation is deceleration. We take it as well. The body has been decelerated. Deceleration. All together. Now let's take this question and solve it. Let's solve the question that is given to us. They give us u to be equals to 20 meter per second, and they give us v to be equals to 32 meter per second. Please note, it is highly important for you to write out analysis of what you are given in question when you have solve phases. Now, they say we should find the average acceleration. How do we find the average acceleration? Since that is said average, we know that my average acceleration is change in velocity over change in time. Did they give us any change in time? I think they said a car is traveling along a straight road highway at a speed of 20 meters per second. The driver steps on the gas pedal, and 3 seconds later. No, they said 3 seconds later. It simply means the change in time that is given to us is 3 seconds. So from here, I can easily calculate by saying my change in velocity simply means my final velocity minus my initial velocity all over change in time. You know, earlier on I said my u is simply indicating initial velocity and my v indicates final velocity. All together. So from here I can easily say my final velocity is 32 minus 20 all over the change in time is equal to 3, which will give rise to 12 over 3, and I'll be having 4. Now the unit of acceleration is meter per second square. That is the unit of acceleration. So the acceleration of the body is equals to 4 meters per second square. Now let's take this example 2. Example 2, they said the position of an object measured in meter from the origin where x is equals to 0 moving along a straight line is given as a function of time by the equation. Please note here, they gave us the position of the distance as a function of time by this equation. St is equals to 40 square minus 60 minus 40. Altogether, now this is what is given to us. Now, the next said we should find its velocity at time t. Now, note something. These are where, what kind of velocity are we asked to find here? We need to know. They say find the velocity at time t. Because they specify a specific time that you're meant to find the velocity that they are requesting from you here is an instantaneous velocity. Sometimes they will say find the velocity at time t is equals to 2 seconds. That means at that instant of time, calculate the velocity, which is an instantaneous velocity. Now, if you differentiate this, st with respect to time, I should be having, don't forget our formula. This will give rise to 4 times 2 t raised to power 2 minus 1 minus 6 times 1 t raised to power 1 minus 1. Then minus, now this 40 here is t raised to power 0. So this thing can be equals to 40 times 0 t raised to power 0 minus 1. Then I'll be having this one as 8 t raised to power 1 minus 6 t raised to power 0. Then this one will be what? Equals to minus 0, because 0 times 40 is 0. I should be having this one as what? 8t minus t raised power 0 is equals to 1. I'll be having 8t minus 6. So my velocity at an instant of time is 8t minus 6. That is my velocity. 8t minus t, 8t minus 6. That is our velocity. That is the first question. We should calculate velocity at an instant of time t altogether. So velocity is also a function of time. Look at, is a function of time t. Now, the second question, I said its acceleration at time t. How do we calculate for its acceleration at time t? Now, don't forget that to get the acceleration of the body at time t, we need some kind of calculation that we need to put. Just differentiate this. How do we find the acceleration? Acceleration can be gotten. Acceleration is always equals to my dv all over dt. Since my v is equals to differential of 8t minus 6 all over what? dt. So if we differentiate this the same way we are doing, we'll be having differential of this one will be 8 minus 0 altogether. So my acceleration at time t will be equals to what? 8. But here acceleration is not a function of time. Are you get something now? So my acceleration is equals to 8, which is 8 meter per second square. Altogether, that's our acceleration at that time t. Now, the next question that is now given to us, they said the time at which the object is at the origin. This is one thing that we need to know. We have to calculate the time at which the object is at the origin. When simply means when the object has not started its motion. Now, at the origin, note something. At the origin, note this, that your s as a function of time is equals to 0 because that time the body has not started moving. So at the origin, x is equals to 0. So if x is equals to 0 at the origin, then we can use our function that x as a function of time, which is equals to 4t squared minus 6t minus 4t equals 0. Altogether, because my st is equals to 0, so everything equals what? 0. So we can easily solve the quadratic equation t squared minus 6t minus 4t to be equals to 0. Now let's find a way of solving this. Let's first of all reduce this equation by dividing all through by 2. If I divide by 2, all through by 2, I should be having 2t squared minus 3t minus 20, everything equals to 0 altogether. So the equation I want to solve here, and I want to find the value of my time t altogether. Now let's solve the equation. 2t squared minus 3t minus 20. 2t squared minus 3t minus 20 equals 0. What will be the factor of this equation? I think the factor of the equation should be equals to 2 times 20 is 40. I think 8 times 5 will give me that. So I need 9. So I'm even the factor of the equation, factors of the equation will be equals to minus 8 and plus 5 plus 5t minus 8t and plus 5t. So we can replace this minus 3t with our factor. I'll be having 2t squared minus 8t plus 5t minus 20 equals 0. And that should be taking 2t squared minus 8t, 5t minus 20 equals 0. And then should be having, this is 2t is common, t minus 4, then 5 is common, should be having t minus 4, everything equals 0. So the final equation should be t minus 4 into bracket 2t plus 5 equals 0. So if I have something of this kind, then it simply means t minus 4 equals to 0 or 2t plus 5 equals 0. So if t minus 4 equals to 0, we should be having t to be equals to 4. And if 2t minus 5 equals to 2t plus 5 equals to 0, then we should be having t to be equals to minus 5 all over 2. So the two values of my time t, the question in option C, they say the time at which the object is at the origin. So the time at which the object is at the origin is time t is equals to 4 or minus 5 all over 2. Altogether, this is the time. Now, the next question, I said the object velocity and acceleration at the origin.
Now, note that in this kind of situation, the negative value will be disregarded. You know, we have the two time that time t equals to minus 5 all over 2, and also we have what time t to be equals to 4. So in this case here, the only time that we'll be considering here is the positive time. What we are simply understanding here is that it simply shows that the body passed through the origin when the time t equals 4 seconds. So we can easily calculate the velocity at that time. So the velocity of the body at that time will be equals to velocity at time t is equals to 4 seconds, will be equals to 8 multiplied by 4 minus 6 if we insert into the equation. Now 8 times 4 can easily give us 32. 32 minus 6 will give rise to 20. That will be, if I remove 2, okay, that will give rise to 26 meter per seconds. Now that is our velocity at that time t. Please note that. So the time that we only consider here is only the time at which it is positive time. We can't have what a negative what consideration to the time altogether. So, and again, note that when we get our acceleration is 8 meter per second square, which is independent of time at this range. It simply shows that this acceleration of the body at the origin is constant. The acceleration of the body is constant throughout the motion. Simply means the motion is assumed to be a uniformly accelerated motion, whereby at time t is equals to 4 seconds, the acceleration still remain 8 meter per second square. Thanks for watching this interesting video. Please don't forget to subscribe to my YouTube channel and make sure that you follow me to the end of this series so that we can get what the best time out of physics, and I'm assuring you of having high score in your physics exam this next year's Jamb. Thank you for watching.